presenting this because since it's kind of like the first time that I'm doing so. Oh, you want to give this a shot?
Just a little bit.
All right. Let's start off from the basics, I guess.
All right.
So 3 very easy questions. How many are you? Are you all together?
No, we're just watching.
Oh, it's just okay. 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 Hey. So you want to give this a shot?
Sure.
All right. Give me 1 second. So 3 very easy questions, and they have to do with water. See if you could get at least 2 of 3. Hey, so you guys want to give this a shot?
I would love to.
Cool. So 3 very easy questions, and they all have to do with water. And see if you guys can get at least 2 of 3.
Great.
So,
what's up?
hey, so I have 3 very easy questions to see if you guys can get at least 2 of 3. You guys
Okay.
can get a shot? Okay, cool. So they all have to do with water, and basically they're elementary physics. Very easy.
Okay.
So this first one.
Are we gonna show up
Are
on
we
like
doing this
Instagram?
together, or we-
YouTube. I have a
YouTube,
I can
okay.
give you the channel after.
Okay, great. Yeah.
So this one I have 3 water bottles, and they're halfway filled with water. And I painted the water blue with food coloring just to make it easier to see, as the water's clear, obviously. And all of these bottles are at rest. You know, they're all still. You know, so the first one here, I have 3 water bottles, and they're halfway filled with water. And all of these waters are at rest. You know what that means, right? They're all still.
Yeah.
So this first one, I painted the water blue with food coloring just to make it easier to see. By the way, all of these water bottles are at rest. But how I'm showing them to you, like this, what's the difference between these 3 water bottles?
The density of the liquid,
No, the density of the liquid is the same in all 3.
where it is,
What do you mean by that? Where it is?
like where the water is. Like
Oh yeah, definitely. Yeah, the water's in different positions on the bottle, that's for sure.
Different.
Why do you think that is? In this one, I painted the water blue with food coloring just to make it easier to see the water.
Yeah.
But these 3 water bottles are all at rest and obviously halfway filled with water.
True.
So how I'm showing them to you, what's the difference between these 3 water bottles?
I mean, like, do you like the reason like why the water is in different places?
Sure.
Orientation.
You got it. The orientation is the difference.
Yeah.
So what tells you the orientation is different from all 3?
Gravity.
What about gravity?
Where the ball is resting on the top of the water.
Yeah. Okay. How would
Gravity pushes down. Water's heavier than air.
water? Yeah, water is heavier, and that's obvious. So if you had to put them all in the correct orientation relative to gravity, what would be the correct orientation? You got it. You got it. You guys got it. Yeah. That's pretty
You're
good.
so smart.
Yeah. Believe it or not, some people don't get it. Most people do get it, but
Because like this is
how I'm showing them to you, what's the difference between these 3 water bottles?
What's the difference?
What's the difference?
Would y'all even know this? Just say yes or no.
yeah.
Do you guys know the difference?
I was
What's the difference? You gotta
Density?
say. Yes, you got it.
density.
So, yeah, it has to do with the water. Definitely.
I have no idea. I would
You want
just
to
say
help them out?
Like answer for it?
Sure.
Yeah.
Orientation, like where it is.
Yeah, orientation on the bottle. You got it. Can you put them in the correct orientation or the way they should be?
Like
You got it. You got it. Perfect. Yeah. And how did you know that?
Bruh. Okay. I mean, yeah. I mean,
It's obvious, right?
I mean,
Yeah. You were overthinking it, right? Yeah.
I'm like, maybe he put some different water in here, like some heavy water or something.
I don't think
No, that's
that kind of water
crazy.
exists,
That's
by the way.
crazy, yeah.
Water that can stick like this. Unless it's Jello.
Yeah.
Water cannot stick like this. sideways.
Okay.
So obviously it was. Like
Okay.
this.
Okay.
So how I'm showing them to you, actually, this is 1, 2, and 3. How I'm showing them to you, what's the difference between these 3 water bottles?
The difference between.
How I'm showing them to you.
Were the pictures taken like at different angles, or are these all in one?
Well, the pictures were taken in the same angle. Is the bottle is there's a difference between the bottles.
Oh, between the bottles.
Between the bottles, yeah, in specific. The bottles are in different positions, I guess you could say. I'll give you a hint.
Different position.
So it has to do with orientation. I'll give you another hint. I took 3 different pictures. One with my bottle like this,
Okay.
one like this, and one like this.
Oh, because of the gravity?
Okay, so you think gravity's making water stick to this side?
I think you. I don't know.
What do you think? What do you think I did here?
I think you just flipped it around like the box.
You did. I did.
Yeah.
Yeah. So the difference is that the 3 water bottles are in 3 different orientations.
Yeah.
Can you put them in the correct orientation they should be? If this is the ground on this side, how can you put them all with the ground on this side? I guess.
With, like,
If the ground is down is this way,
yeah.
how would you put them all in the correct orientation?
Yeah, that'd be the first one.
That'd be the first one, yes.
Like turning the box wise.
Turning the box, turning the bottom.
Turning the box, we go there. And then there.
Okay, but how would you turn this one to put it in?
What about that one?
Oh, how would I turn it?
Yeah.
I just flip it around.
You got it. Yeah.
This one.
Oh, whoa, wait. Yeah.
You got
There
it.
you go.
So yeah, so I actually took 3 pictures. I took one like this,
Yeah.
one like this, and one like this.
Oh, nice.
So again, water doesn't have the ability to stick to the side of the bottle while it's right side up.
Yeah.
That defies physics. That's impossible.
Did you glue this? How is this going like that?
Because I actually took the picture like that. I put this bottle inside a box, and I
Oh,
simply
you just
took
moved
it.
the camera.
Yeah. No, I moved the bottle.
Right,
But yeah, I moved the camera as well, just so I could get the exact same position.
Yeah.
But again, the water's going to show you the correct orientation. Because if I showed you this like this, you know the water can't stick to the top like this.
Yeah.
That defies
Right,
physics.
right, yeah.
So the logical explanation is that I took it like this. Same thing with this one. It's impossible for the water to stick to the top and the ping pong ball in the bottom. You know,
Right.
that's
Yeah.
impossible. So it's you know pretty. So can you tell me which one is the one that I took holding the bottle upside down?
Holding the bottle upside down?
Yeah, which one was I? In which one was I holding the bottle upside down?
I think you're holding the bottle upside down.
Why would you say that?
Because it just looks upside down to me. I don't know.
So, okay, I'll help you out in this one. So the one I took upside down was this one because the water
Okay.
can't stick to the top of the bottle.
I see.
You see that? So I actually took it like this because the water always goes down and the air always
Oh.
rests on top.
Okay.
Would you agree or disagree?
Is the water dyed blue?
Yeah, the water is dyed blue.
I see.
I should have mentioned that, I guess. I usually always do, but since we understand water always goes down
Mm-hmm.
and the air gets pushed to the top, what position will you put this one?
If water always goes down and air is pushed to the top,
Yeah.
then this one's like laid on the side with the water.
Yeah,
on the
like
bottom.
this. Yeah. So again, this water is going to show you the correct orientation. So yeah, so this is okay. You got it.
This
You
is
guys
all
got it.
science, man?
It's basic science.
Nah,
Put it
GGs, I'm
basic.
done.
So this next one's easier. It's easier.
You said that one was easy.
It actually is. Believe it or not, most people do get it. So this one, 3 box trucks. Again, halfway filled with water. In this one box truck is accelerating forward, one of them is accelerating in reverse, and one of them is at rest. So I want to. Okay, so this one, 3 box trucks. Again, halfway filled with water. The water's blue. And in this one of the trucks is accelerating forward, one of them is accelerating in reverse, and one of them is at rest. So can you tell me which one of these 3 box trucks is at rest?
This one.
Why would you say B?
Because the water is flat.
It's not being displaced, right? Yeah, perfect. You got it. So which one is accelerating forward? A or C?
This one is
You
accelerating.
think this one's
forward.
accelerating? Let me show you. So this is forward.
Okay.
See what happened? So
Yeah, the water's going that way.
the water's going this way.
Really? Wait, let me
Yeah,
see.
look. Yeah, I actually took a better picture of that in slow motion, so you could take a look. So, 3 box trucks here, and they're halfway filled with water again. In this one of the box trucks is accelerating forward, one of them is accelerating in reverse, and one of them is at rest. So, which one of these 3 box trucks is at rest?
No.
Bro,
Yeah, you got it.
it's B.
It's B, yeah. Why would you say it's B? Can you explain to him?
Yeah, because if it's accelerating forward, it would be this one. If it's accelerating back, it's that one.
Why would it be this one if it's accelerating
Because if
forward?
it's going forward, the water
Goes to the back, right? In this one, I have 3 box trucks, obviously halfway filled with water as
Todd
well.
has 10 peaches.
I'm sorry?
Todd has 10 peaches. That's
Todd
the
has
answer.
10 peaches? What does that mean?
I don't know. I'm just trying to come up with a random answer like a math problem.
Oh, no. So in this one of the truck is accelerating forward, one of them is accelerating in reverse, and one of them is at rest.
Yeah.
Which one of these 3
Yeah,
is at
it
rest?
has to do with inertia.
He's at rest.
And so yeah, he's obviously at rest. When you jump forward, the water's all going to rush to the back. When you're
Yes.
going in reverse, the water's all going to rush to the front. So we have
You
reverse
got it.
forward and
I
rest.
mean, this one's definitely traveling at the same velocity. That's all you know. You know it's not accelerating.
You know it's not accelerating.
Yeah.
But,
Right.
but if I was to ask you which one is at rest, They say one of them was at rest. It has to be this one.
Yeah, if one of them has to be at rest, then yeah.
Yeah. So again, you got it. This one's accelerating forward because the water displaces to the back, and this one's accelerating reverse because the water displaces to the front.
Yeah.
Because the water has the water
inertia
hasn't caught up.
Perfect. You got it, man. You guys are pretty smart, man. All right, so
I
this.
just graduated with an engineering degree, so.
And I just took AP Physics 1 and I did pass the exam.
Before we go to see which one of these three box trucks is at rest, A, B, or C. I'm sorry?
Honestly, I would say this one.
Yeah, B, right? You got it. You guys agree? B? Yeah, it's the obvious one. Why would you guys pick B though?
Because at rest.
Because the water's at rest. It's not being displaced.
Yeah.
This is the accelerating.
Yeah.
This is the decelerating.
Okay, which one's accelerating forward? A, you got it. And which one's accelerating reverse? Obviously it's C. And what tells you that?
Because if you drive the car, you're gonna get pushed back. Because
Exactly.
Of physics.
Exactly. Yeah. I don't know if you knew this, but if something's actually less dense than air, like a helium balloon in a car, and you accelerate, that helium balloon actually goes forward.
Oh, I did watch a video.
Have you
That's
seen that?
why-
So again, it
that's
has to do with
why-
densities
that's
when you
why.
accelerate something. So that's pretty crazy. So that's pretty good. You guys got this one. The last one's the easiest.
Okay.
How would you describe the surface of water when it's contained and at rest? Before we go to the next one.
Like how would I describe the surface?
Yeah, of the water once it's at rest and contained. Geometrically. Flat. That's a pretty simple way to. Yeah.
Yeah.
Would you agree?
Yeah.
The one-word definition will be horizontal because horizontal will be perpendicular to the vertical.
Okay.
And level is perpendicular to the vertical. Which is
Okay.
horizontal. So again, this last one's the easiest one. Can you see that?
Oh, interesting.
So again, the water moves towards the back of the acceleration, and the air gets pushed to the front
Why is that?
because the air is less dense than the water.
I see.
So, and if you have a helium balloon in a van and you accelerate that air pushes the helium forward. So the balloon goes forward, not back.
Okay.
Yeah. So an apple, if you hang an apple in a car and you accelerate, the apple swings back because it's more dense in the air.
Interesting.
Yeah. So again, it's the opposite. And I can show you that real quick before we go to. Oh, my phone just overheated. Okay, so you got this one. It's pretty easy. The last one's the easiest one. So before we go to the last one, when water's contained and at rest, like in this one, how would you describe the surface of the water? I think you said it earlier.
I don't really know if it's technically flat, but I mean like
Would you say level?
I would say level.
Yeah, level. What would be your definition of level?
I feel like this is a trick question.
Oh no, it's very easy. What would be your definition of level? Like, you've seen it before, right?
I've also never.
You've never seen a spirit level before?
No.
No? So the air bubble in here is to basically level things out to make sure they're perfectly horizontal. So if you have a picture in your house and it's a little bit crooked, you want to make sure it's perfectly horizontal. You use one of these, because liquid and air always displace water, levels out. So again, the one-word definition for level will be horizontal because level is perpendicular to the vertical. So that's another thing. So again, so the last question, when water's at rest and contained, like on B, how would you guys describe the water or the surface of the water? Still, geometrically.
Rectangular.
Like
I guess, sure, but the surface on
like
like flat,
180 degrees.
exactly. So 90 degrees from the vertical, so perpendicular to the vertical.
Right.
That will be horizontal.
Yeah.
So-
like parallel to the drug.
So that will be the one-word definition for level. So have you ever heard of water always finds its level when contained and at rest?
Right.
So again, that will be level.
Okay.
Perfect. So this last one is the easiest one, by the way. So before you guys go, real quick, because the real reason I'm doing this is because do you guys believe objects accelerate down in free fall? Like when that release this, do you believe this accelerates down? Like in other words, do you believe in a pulling force of gravity?
Yeah.
So if we understand physics like acceleration, water in a container, and acceleration, the water, again, if I accelerate the bottle, the water always moves to the back of acceleration and the air gets pushed to the front, right? When free fall, when I actually accelerate this down, the water wants to move to the top. Again, same principles, but in free fall, that doesn't happen. So in reality, the reason why gravity is a theory is because objects don't accelerate down towards the Earth. It's the Earth that's moving up to meet it. So the Earth is in constant motion.
Right. It's not actually a.
Yeah, so objects don't accelerate in free fall. It's the Earth that comes up to meet it. So do you guys believe the Earth is a ball?
Yeah, I'd say so.
How will that work if it's the Earth pushing up against objects moving up in odd directions from a globe?
Because it's moving at like a speed or like.
So the reality is, it would just like be expanding or eventually explode. So in other words, gravity as a pulling force doesn't exist, and it's the Earth's motion, a push. So gravity actually debunks the globe Earth. because there's no physical downwards acceleration of objects. So it's the Earth's constant motion up. So the Earth is a level extended plane, and it's just moving up in one direction. It's not pushing out in every direction that defies physics. You know that.
Right, that's true. Like we would have to like that for the ground.
Yeah, the Earth will have to be expanding in all directions.
Wouldn't everything just fall like then?
But that's the thing. That's the thing. Physics shows us that there's no acceleration down. Water. This is an accelerometer, by the way. Air and water in a container. That's a simple accelerometer. And then you can also get a digital accelerometer on your phone, and it can show you acceleration when you accelerate down, left, right, or up. When you put it into free fall, it registers 0 acceleration. And only registers motion when it's at rest on Earth, showing you that it's the Earth pushing up.
Wow.
You know? So again, in free fall, there's no acceleration. So yeah, so that's the biggest lie on Earth, that objects accelerate in free fall. But you guys can check out my channel.
All right.
And
Thank you.
yeah,
Thank
give it a
you.
look.
Thank you.
All right, man, thanks for the chat. Actually, I have them here already. So out of these two, since we understand what level means, and when water is contained and at rest, which one of these two represents water at rest and contained? A or B?
And this is just like in a regular, like,
A regular container, just a big container. Which one represents level, as you know, when it comes to water?
honestly,
Yeah, we gotta
probably
pick-
this one.
Yeah, I mean,
Yeah, because it balances out. Like,
yeah,
it all
exactly,
wants to be the same.
Exactly.
Like, water
yeah,
doesn't
it's-
work like this.
Exactly, you got it. Do you agree or disagree? You think this is level?
I'm not sure about the dimensions of this, but
Right.
this follows the curvature of the Earth over 3 miles, which is around the horizon from eye level. So
I'm glad
the
you
whole
brought.
curve away from you.
I'm glad you brought that up.
Well, I don't know if it's 2 feet.
So what
per
will-
mile. I don't know. If
So
that's
what will,
true.
what will be your definition of level?
I think it's, I would say, in line with the circumference of the Earth. Maybe.
Would you say equal distance from the center to the outer circumference of the
No,
circle?
because the Earth
Okay.
is wider at the equator.
Oh
than
no,
it
but it's
is-
spheroid,
yeah,
right?
of
Did you
course.
know that that's how they
Because
redefine level in books? It's the equal distance from the center to the
that
outer
doesn't make any sense.
Exactly, it
because
wouldn't.
The
But that,
poles are far closer than.
exactly, but that's how they redefine it in my book, and I'm glad you brought it up because this is what that has to do with. Which one of these two represents level as we know it when it comes to water, A or B?
Like, what does this represent?
This is just a level structure, so it's like a, you could say it's like a bridge above the water. It's perfectly straight.
I feel like this is a trick question.
Oh no, it's not. It's very easy.
This
See?
one?
Yeah, that's the obvious one, right? Because there's no deviation here, so that will be a horizontal surface. This wouldn't be a horizontal surface. This would be a curved surface or a slope, right? So, which one of these two represents water level when it's contained and at rest? A or B?
Contained and at rest.
Hold on. What do you mean?
If it's contained and at rest, wouldn't it have to be A?
Exactly. Yeah, that's the obvious one.
Yeah.
I mean,
Isn't that
what
obvious?
will be your definition of level if not horizontal, right?
Yeah, I mean, I just say like if it's level. I mean, this looks like it could be moving or being
Sure.
poured, but this
Exactly.
looks like it's still.
Exactly. You're right.
Part of me was like, is there some kind of adhesion?
Can
property or
this
something?
water be contained and at rest? Like you said, it could be pouring. That's true. But
Well,
can
but
it be
it-
contained and at rest? No, right?
Unless it's like the it's this shape of like container or something. 'Cause
So
water
you
would
think if
flow
a container is a shape, the water's gonna display that shape?
wouldn't have to because
No.
water.
No, I mean, I was thinking, like, what if it's the surface of the Earth? But I don't think that that's what it is.
No. So again, the real reason I'm doing this, you're kind of getting there, but the real reason I'm doing this is because over 95% of the population have been tricked to believing this is what level means, even though we know it's this and water shows us that. You guys want to know how we were tricked?
How?
You guys believe the Earth is a ball, so you were going there. So over 95% of the population believe this is what level means, but in reality, this is it. Because again, NASA, they claim to have satellites orbiting the Earth, so they need to know the radius of orbit, so they need to know the radius of the Earth. So they do tell us the radius of the Earth is 3,959 miles, which means there has to be curvature every mile, and every mile that curvature has to increase because they're claiming it's a curve, not a slope. So in the first mile, there's an 8-inch drop. Second mile, 32 inches. And by the third mile, there should be 6 feet of curvature. And in 10 miles, there should be 66 feet, which is like a 6-story building.
Yeah.
So if we went out to a giant lake that was miles across, we should be able to physically measure for this curvature.
Yes.
But if we actually did it, the water is going to be parallel to anything horizontal above it.
Oh, this is like flat Earth.
Well, flat Earth is a psyop, and I'll get into that later. But this will be the #1 experiment to debunk the globe Earth claim, a physical measurement of the Earth.
Okay.
And, a direct measure like this over water specifically. The real reason I'm doing this is because over 95% of the population generation, including myself and maybe you, have been tricked to believing this is what level means, a curve, even though we know it's this, horizontal. You want to know how we were tricked?
How?
Do you believe the Earth is a ball like this?
Yes.
So these are official NASA images, and they claim to have satellites, orbiting the Earth to be able to take these. So they do claim to know the radius of orbit, so they need to know the radius of the Earth. So they do tell us that it is 3,959 miles, which means there has to be curvature every mile, and every mile that curvature has to increase, because you're claiming it's a curve, not a slope. So if we went out to a giant body of water, for example, this, like a lake that was miles across, we should be able to physically measure that curvature, but in reality, the water is going to be parallel to anything horizontal above it. So this will be the #1 experiment to debunk the ball Earth claim, a physical measurement of the Earth, water in specific. So a lake, will be more ideal because there's no claims. Again, NASA, these are official NASA images, by the way, and they don't take real photographs of the Earth. So they do claim that they have satellites orbiting the Earth, so they need to know the radius of orbit, so they need to know the radius of the Earth, because they're supposedly going around it. So they do tell us the radius of the Earth is 3,959 miles, which means there has to be curvature every mile, and every mile it has to increase because they're claiming it's a curve, not a slope. So in the first mile, there's an 8-inch drop, second mile, 32 inches, and by the third mile, there should be 6 feet of curvature. So we went out to like that giant body of water, like a lake that was miles across, to physically measure for this curvature. The water is going to show us or displace that it's perfectly level to anything horizontal above it, but they're trying to tell us that that surface of water it's bending 6 feet in 3 miles. So, but that's a physical impossibility for water to do that. It defies physics. So it's like claiming you can walk on water, because water has properties, and again, it doesn't have the ability to maintain a shape on the surface. It always collapses and forms, especially when it's contained and at rest.
Right.
So
It's always gonna fill it. It's always gonna fill it
from the bottom to top, and
right.
the surface always levels out. When you fill up a pool, it always fills it up from the.
And if I flip your bottle like this, like the top is gonna be level right there.
It always equalizes. Exactly. It's one of the properties of water. So if I was to ask you guys respectfully, what's the #1 proof or reason that makes you believe that the Earth is a ball? That it's round. Why do you guys believe
the
that?
#1 reason?
Yeah.
I would say, bro. I mean, can I provide a counter argument?
Sure.
Because people say, oh, like you look forward and it's flat, bro. This is so much bigger than anybody can ever imagine. You're not gonna be able to see the curvature from one view.
Can I rebuttal that real quick? So we do have a limit to how far we can see, and there is horizon calculators that measure that distance. It's around 6 feet if you're like 5.5 feet to 6 feet tall. So the more you elevate, you increase your angle of view, because again, everything shrinks the further it gets away from your eye, because again, we do have a limit to how far we can see. So the horizon is simply our limit of perspective.
Correct.
So it's not a curvature of the Earth.
But the horizon does indeed curve away from you if you elevate yourself from
Well, it doesn't.
ground level.
Yeah, I'm glad you
Are you
brought-
going to say that the horizon stays at eye level if
Yes.
you increase your height?
So this is 20 miles in the sky. What should happen, the horizon should drop below your feet when you elevate, but that never happens. The sun never drops below your feet.
You're saying the fact that the horizon stays at eye level is more
Yes,
consistent
that's
with an object
geometrically-
which is flat,
Exactly.
as opposed to something that curves away from you in every direction.
So let me show you guys what it would look like when you elevate from
What's your background? You know here?
I've had my master's degrees in.
In what though?
I got my first master's in mathematics and my second in chemical.
Okay, check this out.
Well, I'm done with that.
No, I'm saying, but you're very well spoken.
No, yeah,
And so are you.
No, yeah, thank you. I know I've been into this subject for over 8 years.
I
I've been
love it.
So here's the difference between a globe Earth horizon elevating versus a flat Earth horizon on a program. The horizon
Bend away from you in every single
exactly.
direction.
Okay.
The more you elevate, the more it should drop below your feet.
Do you have any arguments with regards to the sun's rays when it would perpetrate through a cloud?
So
Should it all be going straight down in theory? If the
they
sun's
should all
really
be
far away
parallel.
as opposed to-
Exactly, but we have crepuscular rays, which defies that claim.
which is more consistent with an object far closer to the cloud.
Yes, exactly. So the sun is far close. It's part of the Earth system. So the Earth is a contained system. So the Earth, the sun, in my opinion, and the moon and the stars are all part of this system.
Okay,
So, yeah.
I'm with
So
you.
nothing. But if I was to ask you respectfully, what would be the #1 proof to make you believe that the Earth is small?
To me, I just think that because Earth has a very strong center of gravity, and then the water is pulled towards the Earth, I think the curvature is very slight. It's very hard to measure the curvature of water.
Okay.
That's just kind of, to be honest, I haven't really thought about it. I just personally I am a believer in science.
Well,
but-
I think science is a method to prove things, like the measurable, testable, repeatable. So to believe in science, I would say it's kind of a contradiction, because I understand science. That's a difference from me believing it. Because if it's practical and it could be demonstrated, measured, tested, and repeated, then I don't have to believe it. I can understand it or accept it.
what would your proof be that the Earth is flat?
Well, I wouldn't say
Just
it's flat. I would say it's level. And water will be one of the top proofs that debunks the Earth, because the physics of water shows that it cannot conform into a shape and maintain that shape. The surface always collapses and forms an equal surface.
But when you think about water in space, like when it's released, like it's like a ball, right?
You could say that. By the way, all the videos they're showing us from outer space, a lot of them are being like doctored using CGI screens and all that. But I do agree that when there's no force acting on water, it doesn't have a shape. You're right. So it just becomes like a bulge, right?
So in space, do you believe that
So
there's a force acting on water?
So the Earth is a contained system. In other words, because we have air pressure here, right? In order to have air pressure, you need to have a solid barrier, especially if you want to separate it from a vacuum. So if you want to have a vacuum and a pressure system, you need solid containment. Because if you don't have solid containment of the two, they'll just equilibrate.
I'm not sure I understand what you're saying.
So the second law of thermodynamics, have you ever heard of that? No, right?
Second law of thermodynamics?
So basically,
An object at rest stays at rest?
No,
unless
no.
it's actually on outside
No,
force,
that's
or
the
is it
first
not?
law of motion.
Which one's the second one?
The second law of thermodynamics has to do with entropy, and entropy
Oh, is
has
that
to
no
with
energy
gases.
can be created or destroyed?
So it has to do with gases finding in their equilibrium, basically.
Mm-hmm.
So again, if you have a tire, a car tire, and you put air in there, 50 psi, for example, right?
Mm-hmm.
Here on Earth, we allegedly have 14.7 psi. But let's say you fill up a tire and there's a tiny hole on that tire, or just a hole. What happens to the air inside the tire?
Wait, sorry, can you repeat
If
that?
you have air on a tire and it's completely filled, like in your bike, it could be a soccer ball, it doesn't matter if it's contained. And then you poke a hole on that ball, what happens to the air inside?
The air starts to come out.
Exactly, because of entropy, because of the second law. If there's no solid barrier separating two opposing gas pressure systems, then they're just gonna equilibrate.
Is the expansion of a gas into a vacuum. I have in one of these bulbs some bromine, and in the other I have a vacuum. And if I open the tap between these two, you will see spontaneously the bromine rush from one to the other. Now that is the simplest change we can have, perhaps, because all that happens is a change in entropy. In this case, the expansion into a vacuum, nothing else is involved. There's no energy change, there's no temperature change, there's no change except entropy.
Is it because of entropy, or is it because the pressure inside the...
It's greater, yeah.
Is greater than outside?
Yeah, exactly, and it rushes out to equilibrate with the outside air.
But I'm not sure if pressure is the definition of entropy, because isn't entropy like to the extent at which like the molecules are moving?
Sure. You could define it as that, sure.
So I don't really know if it has to do with pressure.
Well, that's the thing, it does, because again, because if you don't increase the higher pressure, then because pressure is the gas molecules pushing up against the walls of a container, right? So that's the air wants to come out, basically. So that's why it needs solid containment, so the air doesn't rush out. So when you claim outer space is a vacuum next to Earth's pressure without a solid barrier, you can't have air pressure without a solid barrier maintaining that pressure, because the air wants to be rushed out. You need something solid to keep it from rushing out.
I don't think that's true when you have a massive gravitational force that's pulling the gas towards Earth.
Yeah, so you're saying gravity pulls the air down towards the center. That's what's keeping the air from rushing out.
Yeah, I mean, I think things in a vacuum behave very differently, right? Like, for example, if you have this water bottle and you poke a hole in it and you drop it in a vacuum, or if you're free falling in an elevator, then gravity is the only force that's acting on the water, and then the water will not come out of the hole.
Yeah, I understand. You want to know why that happens? In reality, that happens because there's no force acting on the bottle. It's outside in outer space. So outer space is just a concept. It doesn't really exist. Nobody's been outside of the Earth, because the Earth is contained somehow.
What is the concept with regards to other celestial bodies that you can see from the Earth?
Yeah. So the concept from a true perspective. All right, man. Here, take my channel.
Yeah,
give it a
for
look,
sure.
man.
For sure. Okay.
Yeah, you could take it. I have plenty.
Is it going to be on TikTok?
Nice to meet you too.
It's a pleasure.
Cameron.
So from a true perspective, what's outside of the Earth, the lights, what are they? Nobody really knows. So, so it's a green light for anybody to just make up any story to fit their bias. So that's what's happening with the globe. They're making up stories about the lights in the sky, the orbits that are supposedly happening and all that. It's just mathematical equations to fit a bias, which is this. It only exists on paper, basically. The globe concept.
I'm with you.
Yeah.
And are you guys arguing that, say, any image of the Earth as a globe is digitally rendered?
Well, we don't even have to argue that. They admit it, that all CGI, all pictures from the outer space are CGI. So they claim the only real one they have was from the moon landings in 1972.
You disagree that's the
But that was all a fucking it was all a movie, basically.
Yeah. Okay. I'm with you.
No, and if they did have a real photograph, because a lot of people say, well, they didn't have CGI back then, but they did have professional painters. So they could have easily painted a globe and then took a picture of that painting.
I see.
Present it as a real photograph.
Do you feel like that would be a big secret to be able to keep it secret?
Oh yeah, I think it is the biggest secret on Earth, in my opinion, what the Earth actually is.
Okay.
And this is the reason why I'm out here, is because not only because it is the biggest secret on Earth, it's actually being censored because of that.
Okay.
It's the biggest topic on Earth that's being censored, by the way, and that's why I'm out here speaking to people directly, because there's a lot of fake flat earthers, I will call them.
Okay, I'm with you.
Yeah, and what I'm gonna tell you, the one thing that separates someone that's true like me and then these flat Earth controlled opposition.
I'm with you.
All flat earthers that are online, especially YouTube content creators, claim the Earth is motionless. So the fact is, I don't know.
But flat earthers will claim that it's accelerating.
It's not accelerating up, it's a constant motion up.
But then if it's not accelerating, how are you creating force to stay planted with the ground?
Exactly. So
because if you were all moving at the same speed, if I was to jump, I will simply continue moving.
Well, that's what we're taught in school, but in reality, you've heard of inertia, right?
Of course.
So inertia tries to tell us that an object at rest wants to remain at rest, and an object in motion wants to remain in motion. But that's a contradiction of the two claims. The fact is, matter wants to remain motionless. So matter has inertia.
Okay.
So that constant motion, because matter has inertia, is resisting that constant. That's why we have weight, and that's why we don't fly up.
So in your theory, inertia is not always increasing. It
No,
doesn't want to increase. It wants
inertia
to
is
stay
just
the same or decrease.
resistance to motion.
Okay.
That's simply what it is, inertia.
That's like some of the old school stuff.
Okay,
like,
yeah,
that's some of the Greek stuff.
they changed a lot of it again to fit this model. And again, they say first law of motion, the object in motion will always stay in motion. That's how they mix in truth with lies.
I understand what you're saying. This is all of the Pythagoras and also Socrates stuff to say that if you roll a ball, the ball wants to come to a stop on its own. As opposed to there are forces acting on the ball which slow the ball, but the ball has no intention of stopping it.
Yeah, because inanimate matter cannot move on its own.
Okay,
that's a fact. You know, it requires an external force. And I
But the force acting on the bottle is gravity. That's the only force.
I don't know if you knew, have you heard of Einstein's theory of relativity? So he acknowledges that gravity is not a force. So he came up with the bending and warping of space-time to explain why objects move down towards the ground. But in reality, they don't accelerate down towards the ground. And the reason how we know that is because, again, when we have air contained in air and water in a container, for example, in a bottle or a truck like this, and we accelerate that container, the water always displaces. The water always reacts to acceleration. That's a fact. Even if I accelerate down, the water always reacts to the acceleration. In reality, in free fall, when we put an object like that into free fall, the water doesn't react to that. And that's why the water doesn't get pushed out, because it's not reacting to any force, because it's not being accelerated down. What's happening is the Earth is moving up to meet it. So the Earth is pushing up against you right now, it's not pulling you down.
But I do believe that it is accelerating downwards.
Well, why do you believe that?
I don't know, because if I look it up, and you look it up.
Sure. Do you know what an accelerometer? Have you ever heard of an accelerometer?
Because the object feels a force, it accelerates, which means its velocity increases as it falls.
Yeah, they're claiming that the object accelerates down, but physics shows us that that's impossible. Just like they're claiming that water curves, physics shows that that's impossible. So
why does physics show that that's impossible?
Because
I feel like people have measured acceleration.
So what they're measuring is the rate of loss of momentum. So again, if hypothetically, I don't know, nobody knows the speed of the Earth because nobody's been outside of it. But let's say hypothetically the Earth is moving at 1,000 miles an hour right now.
I don't know if I agree that people haven't been outside the Earth.
I would say you just have to believe that.
You think that it's like CGI?
Oh yeah, everything about outer space.
What
is
makes
CGI.
you feel like you can believe that with no evidence, in the same way that you think that I'm believing that the Earth is round with no evidence?
Well, the evidence that tells me that it's impossible to go outer space is the fact that you need a solid container to have two opposing pressure systems next to each other. And gravity.
I don't know if that's true, because you can put gas in water, right, and it bubbles. But I mean, it's in there for a second.
Yeah, but it displaces.
It displaces, yes, but I'm pretty sure you can contain something.
So if you're not containing air pressure, it's going to displace. So you're not going to be able to maintain pressure. So again, when you have an air bubble rising in water, for example, it's rising up because there's pressure in the water. I don't know if you knew, in free fall, that air bubble doesn't rise. So if you have an air bubble rising and you put this bottle into free fall, it no longer feels that upwards push. So that force that's pushing the air bubble up is no longer being felt. So the bubble just freezes where it's at until the ground hits it again. And then the air bubble gets pushed up again. Because everything is being pushed up by the ground. So
Everything's being pushed up by the ground.
yes, it's a push. So gravity is a push of the Earth, not a pull. So if,
like what makes you feel that it's a push?
because pulling forces don't exist. So everything that has motion here on Earth requires something else to push it. So even a combustion engine.
But what makes you think that pulling forces don't exist?
Because the mechanism of motion and pressure is push. So if you wanted to move something without using pressure, how would you do that?
To be honest with you, I'm like not great at science, so I might not be explaining this correctly. But I mean, to me, I think just like it's just like energy, right? Like I go like that. It's like I'm pulling it, right?
So
I don't know.
I'm gonna explain to you. Pull is only a description of direction. It's not a force, a mechanical force. So if you want to pull a door open, for example, you have to apply pressure on the handle and push it towards you, but we say pull because it does. I guess it's just something that we've been taught since we were little. When you push something towards you, we say pull. But when you push something away from you, we say push. So you push the door open when it's moving away from you, but you pull it when it's moving towards you. But the mechanism is pressure. Does that make sense? So if I was to ask you guys respectfully, and it doesn't change by scale, I know people believe that, but again, we will have to physically measure a large body of water like a lake.
But like if this was curving, it's like
we should be able to measure that curve, right? If it was. So if I was to ask you guys respectfully, what's the number one reason that makes you believe that the Earth is a ball?
I guess because of the tests that have been done about like if you shine the light that shines through the hole when you place them at a certain distance apart.
Okay. The laser experiment. Right?
Yeah.
Okay. What about you?
I mean, it's the whole theory, not to take apart your theory, but if a ship sails off in the distance, that the base disappears before the mast.
Okay, so I'll address yours first. So when it comes to laser experiments over a giant body of water, those are being pushed in the mainstream, and I'm gonna tell you why. When you shine a laser through water, does that laser go straight?
No, there's
refraction.
Yeah.
Exactly. So when you shine air, is basically moisture. So when you shine a laser through the air, you're gonna get the same thing. You're gonna get refraction. So you're gonna always get an inconclusive answer. So that's the reason why they always push us. A concrete answer will be building a solid structure over a body of water like this, and physically measure that curvature deviating from the level, the further down we get. So this experiment would never be. Oh yeah, you guys are definitely, but again, just before you guys go, because I know you guys understand acceleration and inertia, which actually, I know a lot of people think gravity as a pulling force proves the globe, but in reality, gravity, the real cause of gravity debunks the globe. And the reason why is because, again, if we go back to this acceleration with the bottom, where is it? Where did I leave it? I always misplace that one. So again, the water always gets pushed to the back when you accelerate the bottle. And if you accelerate this way, the water gets pushed to the back. And even if I accelerate down, the water wants to move up to the top because of inertia, exactly. So when you release an object into free fall, we don't get that displacement of the water pushing to the back because, I don't know if you knew this, gravity as a pulling force is just a theory. In other words, objects don't accelerate down to free fall. What's happening is when you release, so the force is the Earth pushing up against you right now. So you're not being pulled to the Earth, it's the Earth's pushing force. It's not a pull, it's a push. So when you're holding an object and you release it into free fall, it just loses momentum. So it's the Earth that catches up to it again. So this never accelerated down to the ground. So it's the Earth that came up to me. So we're always in constant motion. And I don't know if you knew, force is just simply motion. F equals ma. It's matter that's moving, something that's moving. That's what force is. So the fact is, when you accelerate an object into free fall, the object doesn't accelerate down. And you know how we know that? Because when you have water in a container, the water always displaces relative to the direction you accelerate. So if I accelerate this bottle this way, the water moves to the back. If I accelerate this way, the water moves to the back. And if I accelerate it down, the water moves to the top, which is back. In reality, let me just show you. I don't know if you've seen this one when I was showing them. When we accelerate down, we don't see that displacement. In other words, in free fall, it's not accelerating down. Can you tell which one I actually accelerated? Right or left?
You would, the right or the left. It would seem that the one on the right is accelerating, but my assumption is that you're actually dropping the one on the left and you're just shaking the one.
Well, the other one, I simply just went like this, but obviously I couldn't do it perfectly straight.
Yeah. So
but the water does displace to the top. You can see that.
Correct.
Now they claim that gravity pulls or accelerates things to the ground at 9.8 meters per second. Mm-hmm. That's 32 feet in 1 second. So you really think it's possible to accelerate this 32 feet in 1 second without the water displacing?
The counter argument would be that
that defies physics.
Resistance and what have you slowing down.
Yeah, but I don't know if you knew, gravity is actually a theory.
Yes,
And
of course.
because there's no actual measurable force in free fall, and that's one of the simple tests that show that.
The quantum field theory and the standard model have not been aligned yet on gravity.
So you've heard of the normal force that they talk about, the upwards force, the normal force, that's what they call it.
Oh, the opposite to gravity.
Yes. So that's the only real force, which is the motion of the Earth. So from a globe-verse perspective, if it's the ground pushing up against you and it's not pulling things towards the center, how would that work from a globe?
The argument is that the globe is pushing you inwards in every single direction towards the center of mass.
Right. But let's say we could prove that it's not the objects that accelerate down and it's the ground that's pushing up against you or coming in. How would that work from a globe? Would it work from a globe if it's the ground pushing up against you or moving up?
In theory, it would work.
How would that work?
Based on the fact you could argue that not only are we all being pushed against the Earth here, but the other celestial bodies that are claimed to exist, as per you put it, are also falling towards the Earth, such as the Moon, and the Earth in and of itself is falling towards
My question is, I think you're missing it. If we could prove that it's not the objects falling towards the ground and it's the ground moving up to the objects instead, that would mean from a global perspective that the Earth will have to be expanding. It will have to be pushing up in all directions and it will have to be growing. If we could prove that it's not the objects going to the ground and it's the ground moving up to the object, then that wouldn't work from a globe. It would just explode. It would have to be growing, which doesn't make any sense. And that's why gravity as a pulling force is pushed on us since we're very young, because that's the only way they're able to sell this model. Because if you actually understood that it's the Earth's push, not a pull, the Earth's motion that's creating gravity, that wouldn't work. You couldn't push a globe.
Sorry, I have to go to level.
Sure, I understand.
But so when you say that the Earth is like moving up to meet you, like do you mean like? Sorry, I think I'm having trouble visualizing.
It's moving up
like
literally.
Like literally, like in space, you think that's moving upwards?
Yes. So when you release an object, again, the object doesn't go towards the ground; it's the ground that just comes up to meet it again.
That's an interesting theory.
Sure. I mean, that's what physics shows us against buoyancy. You can't have buoyancy without acceleration. That's why displacement happens when you accelerate a bottle. Air bubble, if you have an air bubble here in the center, for example.
But I mean, I think the thing you're saying about water, like your explanation for why the Earth is flat, right, is that water is less dense than air.
No,
and you think that it needs to be contained in a solid container?
Water needs containment, first of all.
But it's like contained in like nothingness. Like in space, like there's like not air.
But
I figure it's just contained.
Yeah.
The fact that it's nothing.
So this reference frame of outer space, we don't live in outer space. We live here on Earth. And
but
here on Earth.
What makes you think that? Do you think outer space is real?
Well, whatever's outside of the Earth, whatever medium is outside of the Earth, I don't know what medium that is because I don't think.
Do you think that it's solid?
I don't think there's an empty vacuum outside of the Earth. I think there's another medium.
But what makes you think that? Like, is there evidence that makes you think that?
Yeah, nature abhors a vacuum. So empty space cannot exist. We cannot create an empty space as humans because that defies physics.
I think people create vacuums pretty often.
They can't create 100% vacuums. You could look that up. They could try to get near perfect vacuums, but they cannot. We cannot create perfect vacuums. That defies physics.
I'm sure no vacuum is perfect, but I'm sure space is also not a perfect vacuum.
Again, in my opinion, when it comes to outer space, human beings, in my opinion, have only gone up like about 25 miles. So anything higher than that they're claiming is just made up. They're not really going that high. So
what makes you think that?
Because any aircraft, helicopter, airplane, they're all designed to push off of the air when they fly, like the thrusters, and it requires the air to be at a certain density. So the most dense air is here lower on Earth. So the higher you elevate, the less dense the air is. So the less something's gonna be able to push off of it. So eventually you can't fly anymore once you get to a less dense air above. That's why airplanes have a height limit, and helicopters also. But when it comes to spaceships, something magical happens, and they're able to actually supersede these heights, which no other aircraft can do that. Again, that defies physics as well. You can't have something push off of basically nothing to be able to move. Because boats push off water, airplanes push off air, cars push off the road. Everything needs to push off of something else to be able to move.
How do you explain that when water is in a graduated cylinder when there's a meniscus?
Sure. So I would say that's just a different.
You would just say that that's surface tension?
Surface tension, yeah. I don't know. I haven't got into that much, but I don't think that explains how water can stick to a ball or.
I don't think that necessarily explains how water can stick to a ball, but I know that water very strongly sticks to itself.
Yeah.
And that's part of the explanation for those little bugs that can like walk on water.
Mm-hmm.
So, I mean, I don't really know much about science. I'm like studying psychology, but I think maybe that could have something to do with why like the Earth would be round. I don't really know.
No, I mean,
So are you arguing that the Earth is flat?
I'm arguing that the Earth is a level plane because level is an orientation relative to the vertical, which is the Earth's motion. So water is relative to the Earth's motion, level.
So you're arguing that
the Earth is pushing up.
That the Earth is a globe, but that
No, the Earth is not a globe. So it will be impossible for the Earth to be a globe because if we could prove that it's the Earth's motion or the Earth's force pushing up against you and it's not the pulling force of gravity, then that would mean from a globe perspective, it would have to be pushing up in all directions, which would mean that the Earth will have to be.
Shape is the Earth?
It's a level plane and it's only moving up in one direction. So up is it's the same for all of us, everybody on Earth. Up is the same for everybody. Again, it's not a ball. It will have to be expanding in all directions to explain why objects don't accelerate in free fall. And that's why Einstein came up with his theory of relativity to explain that it's the bending and warping of space-time. So he doesn't claim that that's a force. He's claiming that that's just the flow of space that's making the objects move towards the ground, but not accelerating them supposedly, but it is moving them. So that's like double speak, in other words. Yeah. So Einstein just came up with that explanation. It's not proof. It's just an explanation so that people accept this. But the fact is the Earth pushing out. You know? So here, take this information.
I might go get lunch real quick.
Yeah. Okay. Take this with you, and then in there are the 6 main proofs that debunk the globe, and my channel's on there as well. All right, check it out, man. All right, have a good one.
What do you think is the incentive to sell the globe model?
If not, I'm not the one lying, so I don't know exactly why they're doing it, but I can theorize that they're doing it for control. So they tell us this when we're really young. It's like a cheap shot on our common sense, so that we just accept authority over our own authority, you know. And then basically we just do what we're told at that point. We just trust other human beings that we think are smarter than us, and then we just basically dumb ourselves down in a way by trusting someone else opposed to our common sense. You know what I'm saying? So I mean, do you have any questions for me?
No. I love looking at all this kind of stuff.
No, you're really open-minded. So is there a possibility that we have been lied to on a mass scale? That the Earth is a ball?
It's tough for me to say. It's for me tough to say that there's a bunch of independent astronomers, people that work on their own, all coming to the same conclusion the Earth is round. When in fact maybe it isn't. But like you say, if there's some sort of random work at play that would make you think that it is indeed round and not flat, and of course if you look for the evidence that should tell you that it's round, then you're going to.
I would say, to me that doesn't really make sense.
Mm-hmm.
Like the fact that there is surface tension on water, I would say that's a separate discussion.
But that would be something that just like look into.
It is interesting. I would agree that what's causing that, right? It could be electrostatic forces, you know, who knows? You know, like how water sticks to you when you shower, it doesn't completely dry. You know, a lot of people like to bring that up, like, oh, water does stick to objects, you know. Like, but I agree that small amounts of water do stick, but when we're talking about large amounts of water like this, you know, like the oceans, for example, it's a physical impossibility for that surface to maintain a curve, especially at the rate they're telling us.
But in the same way that nobody has like kind of proven the Earth's curvature, do you think it's strange that nobody has like walked off of the edge of the Earth if it's flat?
Well, again, in my opinion, the Earth is a contained system. So there is an Antarctic treaty that prevents people from independently exploring. So if you were a millionaire, or if I was a millionaire and I wanted to actually explore the Earth to see the limits of it, I wouldn't be allowed. Now, this is on paper. I don't know if it's actually true, but the UN, the United Nations did sign an Antarctic treaty that keeps people from actually going south and finding out what's actually at the extremities of the Earth.
I don't really think that's what the Antarctic treaty says.
No, it's their explanation is for the penguins to protect wildlife. That's why they don't allow people to explore. Again, a lot of these astrophysicists, if you ask me, they start going against the grain. I don't think they'll have a job anymore. So their livelihoods at stake as well. So a lot of these people that are already in these positions where they're comfortable making good money, even if they did realize that, oh shit, all of this is just bullshit, you know, I'm not really doing anything, I'm just looking at lights through a computer and coming up with assumptions, then they're not going to put all their earnings, their livelihood at risk just to go against the grain. You know, it's kind of with animals too. You don't bite the hand that feeds you in a way.
No.
So with these people, they kind of got them by the balls, if you ask me.
Okay.
You know, everybody that kind of has a degree and is preaching the globe Earth, they couldn't go against it because then they wouldn't have a degree. You know, it will get revoked or something. You know what I'm saying? Like,
exactly.
So any questions before you go?
No, I got to run to practice.
No, here you go, man. Take my channel, and I go to different universities.
Sure thing, man. Hey, keep doing what you're doing. Really fun.
Thank you, man. Appreciate it. Yeah, you too.
There are a lot of, I guess maybe you don't believe that like scientists are necessarily like in the interest of like the common person, but I know that there are a lot of scientists that are in Antarctica, so it's like they've been there.
Yeah.
But you think that they're just hiding it from you?
they're there. They're not proving anything, though, in my opinion. They're just there on base. They just do what they're told. It's only a very small people that actually have to know what's really going on, and everybody else below them are just workers. And that's why NASA is so compartmentalized. I don't know if you knew that. People that build, the rockets are different from people that build the wings, and people that, everything's compartmentalized.
To me, though, I think that's because engineering is specialized. So it's like, obviously, like if you have someone who's really good at making wings, you're gonna have them do that, as opposed to like people not doing specialized labor. Like I think like during the Industrial Revolution, we kind of got away from that.
Sure.
So I don't necessarily know if that's why NASA's compartmentalizing. That's like an interesting idea. For sure.
You do know that a lot of people in NASA, especially in the military, have you ever heard of NDAs?
Like a non-disclosure agreement?
Exactly. So a lot of these people sign NDAs, right? The people that work for NASA, government, military.
It is 11:56. I unfortunately have to go, but I might come back.
Oh yeah, no worries. So here's my channel. If you don't come back, you can check me out. That's my channel.
All right, interesting.
Yeah. All right.
Oh, sorry.
It's okay. All right. Take care.